The transportation problem is solved in two steps. The first step is to find out the basic feasible solution, and the final one, the next step, is the optimization of the transportation problem or basic feasible solution by MODI method. The initial basic feasible solution is generally done by three methods. First one is northwest corner rule, and second one is matrix minima method, which I have already discussed in my previous videos. Please check that. The same problem now is being done. The method the Vogel's approximation method. The same problem is being taken. You can solve the transportation problem by doing any method, but the best method is BAM method, by which you will find the basic feasible solution. Okay, the same problem now is being solved by BAM method. How will do? Acha, I have already discussed. First, you will check that this is the balanced problem. That is the total availability. In this case, 100 units. If you add this, 100 units is equal to the requirements. That means the production units and the requirement or demand units are same. This is called the balanced transportation problem. If it is not balanced, that is, if the requirements or the sources or availability is different, then it is called unbalanced transportation problem. In that case, some modification is required initially, and then you can solve by the same method that I will discuss today. The unbalanced problem will be discussed in separate video. Okay, now I am going to discuss the BAM method for solving or finding the initial basic feasible solution. I will proceed. Take first row. Find out the lowest cost, in this case 8, and the immediate lowest cost, and note down the difference. That means 9 minus 8 is 1. Similarly, for second row, the lowest cost, which is 2, and the immediate lowest cost is 3. The difference is to be noted here, that is 1. In this way, third row, the lowest is 4 and the next lowest is 6. The difference is 2. And last row, the lowest is 6 and the immediate lowest is 7. That's why the difference is 1. The same process is to be followed for each column. For first column, the lowest cost is 5 and the immediate lowest cost is 6. That's why the difference is 1. For second column, the lowest cost is 2 and the immediate lowest cost is 6. The difference is 4. For third column, the lowest is 3 and the immediate lowest is 4. That's why the difference is 1. Now, check all the differences elements this and find out the maximum differences. That means out of 1, 1, 2, 1, 1, 4, 1, which is the maximum difference, maximum element. The maximum element is 4. This indicates you have to allocate in this column. If the maximum difference, say 5, in this place instead of 2, if it is 5, then the allocation will be made in this row. Where you will allocate in this case 4, that's why I have to allocate in this column. How will allocate? Find out the lowest cost or lowest element of cost. In this case it is 2. In this column the lowest cost is 2. That's why the allocation will be made here. The allocation rule is same as I have discussed in my previous video. The northwest corner rule, matrix minima method, same rule. That means out of 20 and 26, the lowest one will be taken here. Why? That I have already discussed. You can see that video. That means I am going to allocate 20 as this is the minimum, and for that reason this will be 0 because the entire production have been shifted, allocated here, and the requirements will be net 6 because 20 have been satisfied for this warehouse. 6 units is still to be allocated. As total units of production have been shifted, that's why there is no scope for shifting further to the cells. That's why I have blocked that two cells. Mistakenly, I should not allocate any quantity here. The similar process repeat for the remaining rows. That means in this case, as there is no change, the difference will be 1. The same process you will follow. The difference, the lowest cost and the immediate lowest cost. In this case, it is 1. To save time, you can put directly. But in the case of column, it will be changed as one cell is blocked. That means take the lowest cost 6 and the immediate lowest cost 7. The difference is 1. In this case, for this column, the lowest cost is 6 and the lowest cost is 7, immediate lowest is 7, the difference is 1. This cost will not be considered as already allocation is made to this cell. And for this case, the lowest cost is 4 and the immediate lowest is 8, that's why the difference is 4. Now again check which one is the highest difference. This is the highest difference, that's why you have to allocate in this column. And how will allocate? Find out the lowest cost cell, lowest transportation cost cell. This is the cell you have to allocate the production quantities. The rule is same, 30 and 49. That means the minimum is 30 and 30 will be allocated here, and for the result is 0. That means the balance is 0 and that will be 90. The balance, that means the required quantity for warehouse G is 90, but production units have been fully shifted to this cell, and for this reason we have to block this. You cannot allocate further as the total quantity available for this factory have been shifted to warehouse G. The same process again we have to continue. That is 1. Difference is, say, the lowest cost. No, sorry. The for this column 7 is the lowest cost and 10, the difference is 3. For this column 6 and 8, the difference is 2. And for this column the lowest cost is 8 and 9. We get that the difference is 1. There is no change, that's why the difference will be 1. And this is cross as allocation has been completed for this, and for this case 0 is there is no scope for shifting, that's why cross. And in this case the lowest cost 6 and the immediate lowest cost is 7, that's why 1. Find out the highest difference from this. This is the highest difference. That means you have to allocate to this column. Where you allocate the lowest element, you have to allocate against the lowest cost cell. That means 7. How much will allocate? 25 out of 25 and 35. The minimum you have to note, that is 25 is the lowest, 0, and the minimum, that is 10. The difference is 10. As it is 0, that means you can allocate in any place here. You have to block it. And the same way again you have to find out the difference one. As this column is blocked, put cross, and in this case the lowest is 6 and immediate lowest is 8, that one is 2, and this is 8 and 9, 1, and row wise 8 and 9, the difference is 1, and this is blocked, completed, this is also completed, and for the 6 and 8 the difference is 2. Okay, then find out the difference, highest difference, this is 2, highest difference, and in this case the highest difference is 2. So if you take this one, the highest difference, then your allocation cell will be this, as this is the lowest cost. And if you consider this, that is this column, again the lowest cost 6. That means the cell where you have to be allocated is this. That how much you will allocate? The 6 and 10. The lowest is to be allocated here. That means 6, and that's why it is 0, and the remaining balance is 4. And as this is saturated and 0, there is no further requirement. That's why you cannot allocate here. You have to block it. So only one column is remained. It is definite that you have to put here, as some element is remains, and here is also. How much you can allocate? You can allocate 4 is the balance. That means 15 is left, and this is 0, and you have to allocate 15. This is 15. So finally all units has to be completed. In this way you can find out the initial feasible solution or basic feasible solution. So what will be your solution? The basic solution is you have to shift from A source or factory to G destination 50 units, from B factory to A firehouses or marketplace to 80 units, from C factory or to G warehouses 30 units, and from D factory you have to shift 85 units to E warehouses 6 units, to F warehouses and 4 units to G warehouses. You can check that the allocation has been completed. How you check? The available wise 15 is okay. Then for factory B, this is 20. The entire production unit has been shifted. For factory C, 30, and for factory D, 85, 31, 35. Satisfied? And for warehouse Y, you can check that all the requirements have been fulfilled. 25, if you add 25 and 20 plus 6, 26, and 25, 30, 45, 40 times. In this way, you can find out the basic feasible solution for VAM method. Now, what will be the transportation cost for this case? Transportation cost will be 15 into 9. The process is said as per unit transportation cost is 9, and 15 units are being shifted here. That's why the transportation cost is 15 into 9 plus 20 into 2, 20 into 2 plus 30 into 4, 30 into 4, 30 into 4 plus 25 into 7 plus 6 into 6, 6 into 6 plus 4 into 8. You can calculate it, and whatever it would be, that is the minimum, that is the transportation cost by this method, and that will be 538, but this may not be the minimum cost. What will be the minimum cost? What will be the best allocation? For which you have to apply the second step, that is MODI method, that I will discuss in my next video. By MODI method, you have to improve this allocation step by step, so that the total transportation cost will be minimum, and that will be your solution for this transportation problem. And in that case, the allocation will be changed. That will be discussed later on. Thank you, and this is all about your VAM method. If you have any question, you please ask to the video in the comments box. Okay, now please wait for the next video to understand the MODI method for optimization of this basic feasible solution, or optimization of the transportation problem. Thank you.